earnest or not. When you first started your endeavor, it's like, are these guys really wanting us to port their software to our platform? Hopefully you saw today why we were so enthusiastic about it. I noted, and perhaps you noted as well, that there were, especially in the high-level environments talk, we had two of those demos were on Leopard. And I love, someone asked Matthew, I don't know if Matthew's still here, someone asked him do you have, Solaris? Do you run on Solaris? He's like, I don't have a Solaris computer. Like, what is Solaris? Isn't Solaris like a bad novel by some Polish guy? But the fact that we're still getting, for us, it's tremendous value to get that into the DTrace community, to get things like air and airline and all that stuff, things that we would have no other way of getting were it not for these ports. So I just want you to know that, hopefully you know it by now, but these ports are enormously important to us. And it's important for the success of DTrace, and we're excited to see it because I think it helps everyone out. So with that, I'll turn it over to Steve and James. Yeah.
We never discussed at the beginning what the information dissemination policy is after the.
With the exception of various bodily threats made to certain other companies, this is connected to this recall. So. Hopefully you did too when you were presenting, but if you didn't, like, let me know. But yeah.
If there are things that were said, not necessarily that you don't want on people's blog, or make that clear, and we're all on our system here.
Okay. With that, Steve and James from the Leopard DTrace team.
So I thought I'd start by sharing. Block this before I go on. Sort of an anecdote about the kind of deep mess I've gotten myself into. We said in January we shipped 5 million copies of Leopard in the first 3 months, all those with DTrace. And one of our customers had a problem. This customer hosts a national radio show. And he runs a couple of Mac Pros to do his mail. He claims he won't answer the phone anymore. All he wants to do is use email. And he's got this problem, and he reviews the problem in his blog. And he says he actually made an on-air appeal to Steve Jobs to come fix this problem. And I guess he was heard. Because Apple engineers, not me, but people I know, were put into the service of this gentleman and finally solved his problem using DTrace. Is that a conundrum?
Yes, like that.
Man. That is amazing. And so sort of the money quote here is, on his show, he announces, I just wanted to take a moment to thank people at Apple. I'm not going to mention the name of the engineer. I would love to, but if I did, this guy would be taking heat for the rest of his career from people for helping me. And for the first time in my life, I kind of agreeing with my So,
Steve, is that engineer you?
Yes, the first line you posted. We did. We won't say what we're going to do with it.
So, I really didn't have much prepared to talk about monologue. I think we're happy to do a dialogue here.
Can you just say how did it happen? So you had some meeting set for DTrace or
God, no.
Oh
God! No, I was searching for something to do. Right? I work in a performance group, and we've come to the end of one cycle for Jaguar. Is that what you call that thing? The previous one? Tiger. Forever ago, and sort of vague unease about. I work in a performance group, but I can't seem to get any observability into the thing I work on really well. I mean, there's this old collection of tools that 2 guys in the company kind of know how to use, and it's just I read this DTrace paper and said, shoot, these guys got it coming. And sort of lit into it, hoping to ask permission later. And sort of started the port on the user land side, which went very quickly, brought up like a profile of tip providers rather quickly on the kernel side, and away we went. James joined on roughly 6 months later that summer, the following summer, and kicked the user land side into high gear, got the USDT probe going, got the tip provider in shape.
I had an advantage. I had seen some of Brian's work when I was still at 7. So as soon as he said, we're doing a DTrace port, I was like, sign me up.
I said from our perspective at Sun, the first we heard about the Leopard port was that they wanted to have a meeting with us. And I was like, man, I do not want to have a meeting. So I told the Apple, I'm sure they're like, there's, I don't know, making a Stanford where they want a demo, or like, so they're IT ops guys. And so we were like, listen, if you want to meet with us, you need to come up to San Francisco. We're not driving down to Cupertino. Like, okay, we want to bring 6 people up to San Francisco. Is that okay? Like, that's cool, but all right, are you guys serious about this? And we met with these guys, and all of a sudden, they're asking us all these really deep, big questions. It's like, we're like, 3 of us like, I don't even know the answer to that. I have to go look at the source code. Like, well, I looked at the source code a second ago. Let me tell you the answer is. And you know what the answer is. And at unlike at Sun Microsystems, we cannot keep a secret. At Apple, they can't not keep a secret. I mean, it's so these guys were basically at that point very, very close to a complete port by the time you first started talking to us. So I was very impressed about how far they had made it. And then we, of course, you guys did the bring up. And so I would love to ask a question. I don't know if you guys have specific things you want to talk about. But actually, maybe worthwhile to get all of the porters on stage, just to so could I get John and Colin? And so John Burrell did the port to FreeBSD, and Colin did the port to Unix, which I mentioned earlier. Got strong emotional ties to it. And it's interesting because all 3 of these teams took different approaches to the problem. And I think each of you did kind of interesting work in your own right. So I guess the first question I would ask is, what were kind of the biggest initial obstacle to kind of that first begin enablement? And I know you each have different answers, so whoever wants to answer that first can jump in. I know, John, you reinvented the universe before you. In terms of the cyclic provider and taking the cyclic subsystem and everything, and CTF. I was very impressed with the degree of Solaris facilities that you ported to FreeBSD, porting CTF and the cyclic subsystem in particular.
Okay, are you up to date on where we ended with that?
No, just kick it out.
Okay. So the current state of FreeBSD is that userland stuff is pretty much done in terms of the build side of it. And the client side of it. Userland tracing is still a big issue because of big props. When it came to getting the build system to work, it just mostly fell out. Once the system 5-isms were converted to BSD format, like for instance the extra level of indirection for IOCTLs, the fact that we don't have an object file system, we don't like using a process file system even though we have one, so I'm not allowed to enhance it. Once those sort of things were sorted out, that side fell out pretty well. So now you can take a source stream from FreeBSD, you can type make universe, and it will build on 32-bit Intel, 64-bit Intel, AMD 64, Spark, PowerPC, and AMD. And ARM. Very soon to Linux as well.
And does DTrace work on all those platforms?
DTrace in the kernel, the support isn't there yet, but all the CTF and everything goes in.
Okay, cool.
It's all ready and enabled.
So I can do a DTrace minus and begin on all those platforms?
Well, yeah, I've got to the point that actually building the kernel just because we haven't got the trap handling. There's no point in doing kernel software until I can do that. So I've been concentrating on getting the DTrace test suite to work. I'm up to 877 tests out of 1,026 or something.
So actually, that's a good question for you. Did you guys, I know, John, you made great use of the DTrace test suite.
That's the only way of knowing whether it works.
And did you guys use it at Apple? You guys were using Test Suite.
Absolutely.
And Tom, were you at?
Oh, we haven't got that far yet.
Okay.
Yes, we are going to.
Cool. Very good. And I mean,
Oh, we had Port of DTrace.
that's great to hear. I think that's very validating. I think I don't know. I mean, I think the three of us have said that one of the mistakes we made in DTrace is that we didn't get going on the test suite early enough. And we rectified that mistake on subsequent projects.
Well, and we open sourced it for these guys.
Yeah, right.
Just to make it so that,
That's great.
you know, both to give you something to help your own development, and also something to sort of say, this isn't DTrace until it's components of this.
I waited for a year after getting the test suite going to ratchet down everything that it showed us.
So I have a question for you guys. So I assume with the DTrace port that first thing you want to do is, DTrace minus and begin, and then you have something that's legitimately some sort of DTrace port. Where did you start in that, or what was the biggest obstacle just to get to that point?
Well, for me, it was the cyclic times.
Okay.
Because DTrace depends on the dead man. So until you've got that, even if you don't have the profile provided, you still don't have the cyclic. In FreeBSD, we don't have the lock levels that you have, so in order to get the cyclic to work, once I accepted the fact that I couldn't make it as a general thing for everyone FreeBSD to use, based on open Solaris code, I just gutted the lock level so it only has effectively the hardware level. But other than that, it works as I had to take out the CPU set stuff. Because what does Nokia now fund? They fund development of CPU set stuff.
Yep. For us, it was, there was a lot of Solaris systems in the support mode. It took quite a while to get my effect. I started trying to port the valve. Tried to our valve, which was just kind of worthless. I ended up using the FreeBSD valve. We had nothing in the way of the proc. We do have the proc.s file system for debug control, so it's probably going to be portable. But yeah, I think probably one of the biggest problems that we had was the IRTL interface that you came up against as well. When we receive an IRTL, we can't see the user space of the client application, so we actually needed to transfer all the buffers straight through.
So I just talk about Phoenix for a second, because you got a completely different problem because of their very different architecture.
Well, yeah, we do too, because the different level of interaction. So the way that our code looks, it's hashift f sum, your IOCTLs, else ours. They're completely different.
Yeah, Unix is a microkernel, so very little actually runs in kernel context. All of the file systems, all of the networking run as user applications. They all register prefixes, file system prefixes, kind of like slightly Plan 9-ish, but
Or Sprite-ish for old timers.
yeah. So we initially put DTrace actually as a user level program, mostly because we could, and it made it so much more easy to debug. The way it hooked into the kernel was, well, we already had a long history of tracing statically defined trace points. And they numerous and highly frequent. They log all sort of interrupts, protocols, scheduling events, and we had the ability to attach a user interrupt handler to each one of those ones. So we basically had DTrace register these handlers, and it would track them. We would copy out all the information in the code context. It just worked. It was really cool. So basically, ported just a couple of the simple, very generic providers that didn't require too much Unix systems, and then ordered a message passing provider, because all of our I/O is messages, reads, writes, controls. So it basically peeked into the header of the message and constructed a provider based on that.
Yeah, that's got to live in the microkernel. I mean, that's got to live in the part of rock that is the microkernel back in the day.
Yeah, eventually it will, I think.
And so how are you able to do the microkernel? How are you able to see messages?
Well, when the microkernel, the message passes a kernel call, when the user application does a kernel call, it tracks and it actually changes address space into the DTrace daemon and runs an interrupt.
So you're able to instrument the kernel from outside.
Now, the limitation of this approach is that it can't really see the message that was being sent. It sees the first little bit of the message. It which is excruciatingly most often not quite enough to see really what was going on. You see, it was an ioptol, and you missed the subtype. Oh man. But so this is one of the reasons that truly putting in the kernel is probably where we're going to go, so you can really see the entire message if you want to. But in terms of getting it up and running, it's ideal.
What would dtrace be as a percentage? Just to have some sense of scope. Is that a really significant thing to take to the size of the customer base, or is it minor? Is it 1%?
In terms of the size of the kernel, dtrace.
I know kilolines is probably as better as well.
Yeah. I'm just trying to remember. Like, I would say that dtrace is pretty much about the same size as the Unix kernel. So yeah, it's really big.
Now you have to know that the Unix size of the Unix kernel is a bit of a party line.
Oh yeah. Well, when you add in all of the user daemons that make up the OS, yeah,
right.
it's
Well,
probably
because there's no process management. Right. There's no all that there is. Unix has historically used rings of protection to have all what we think of as internal facilities are able to be handled at user level, even though there are processes for which the system cannot survive the death. I don't know, maybe they can't now.
Yeah, well, we have PID1, which is the process manager who actually creates and destroys processes. Well, kind of here an incestuous relationship with the kernel. He has privilege. But pretty much everything else here runs as a user process. You can start and stop file systems. And you're right, the system basically depends on those things being there. It's not the panacea to everything. It does make it somewhat more robust.
But it is pretty amazing to watch your file system say, well, and just start it up again. Or
Yeah.
TCP stack and say, well, just a total aside from having worked at Unix, one of the things that I didn't appreciate was that because these things can be restarted so easily, the quality tended to be actually quite a bit lower. And the worst TCP IP stack on the fucking planet was in Unix. Because the thing would just die all the time, just restart it, you didn't care. No one cared. You didn't even bother to fix the bug because it didn't ditto FSys, right? I mean, it's like because
we had a customer.
No. This is the old FSys. This is pre-calling FSys. So.
That's kind of both a blessing and a curse, because we had a customer that had a serial driver, and they were running it with the fault protection management system, which basically detects processes dying and restarts them.
Right.
The serial driver was dying every couple of seconds, and they didn't notice. But yeah, it's a very interesting process, and one of the things that once we get a bit of time to go further with what we're going to have to look at is the fact that, for example, the I/O provider. The kernel knows nothing about I/O other than someone sent a message to someone else. There's no information about the file descriptor, the position within the file, the name. It's all within the user application. So all of that stuff is going to have to be some sort of user level protocol for the tracing. So I don't know exactly whether we would take the I/O provider and make a USDT version of it.
I mean, yeah, for whatever it's worth, I would think you want to make a USDT version of I/O, and then you should still be able to correlate. When FSys initiates an I/O, you know when you're doing it, right? So FSys can have a USDT probe and it's initiating an I/O. It can actually, it knows when it's happening. In fact, it's easier than in the kernel in some cases.
Yeah.
So I think, sorry. Yeah, no, anyway, USDT I think is going to be the way to go.
So during the virtualization talk, sorry, I want to make sure we get on. John mentioned something that sounded a little bit like running a dtrace server on the equipment. That they were going to use sort of L0 as a life support system for dtrace. Any cautionary words about that work? So if you're finally putting in the kernel, do you think that's the wrong way to go? Or?
Well, I think we haven't actually taken it to the kernel yet. I don't know exactly how far we're going to go. I have an actual hesitancy to put too much into the kernel, just simply because of the level of trust. But, well, in some cases it just comes down to performance and access to information. I think Brian was put it on the head with, because so much of the information that we're looking at is actually it's only in user level processes. And the way that the USDT is set up right now pretty much has to be the kernel that handles those traps, unless you actually have an individual VM within each one of those applications. I think it's going to work. Yeah.
in the right context, and that's why I was thinking about, do you have that same issue, but it's not then not quite as much of an issue as it would be like
Alex, the DTrace minus N, what was the stumbling block, or how'd you get there?
by the time I got there, it all works.
Like a huge swath of the stuff just came right up. And funny, I think I did dtrace my SNZN in user space just to see it work, and then began, oh, let's get this into kernel. A couple of Solarises, a fair amount of stubbing at the beginning. Just, oh, let's just make this work and see how far.
There's still an awful amount of stuff stuck down there.
So we all do stuff. It's bigger to refine it.
Yeah, it'd be good to just get for us to get a look at what that's looking like for you. Because I mean, until we know what you stubbed out, I mean, we kind of forget the stuff that is foundation to us that doesn't exist everywhere. So
One of the things that affects us all, compared to you, is the fact that the dtrace device and the kernel has all the Solarises in there, like all the module handling.
Yeah.
We just have to slab that whole thing.
yeah, so we should take a look at that and figure out what I mean, we try to keep that as neutral as possible, but obviously it knows about model lock, it knows about
So there were a lot of, or I should say a lot, there were some interesting impedance mismatches. Depending on your perspective, you can either say Solaris is very featureful, or OS 10 is slim and trim. So
positive either way, James. That's diplomatic.
we have no slash box at all, for example.
Right.
So especially with the user space stuff, where you needed to track fork and exec and various other process changes, trying to understand the semantics of what does it mean when you take a proc lock on a process. When are these things going to deadlock? There was very good documentation of how the locking worked, but it kind of assumed you understood, well, when I take this lock in Solaris, these things are protected. And I found out some of the things on our side weren't the hard way.
Yeah, we found out our way too.
Some of you on dtrace discussed may recall the Pitlock Proclock seminar series held between James and Adam.
Yes.
It's like, I didn't think both of you were reading the email. I think it's like I don't think anyone, I think you were both writing it, no one was reading anything.
So we had problems with the locks because of the fact that you allocate memory holding a lock.
Yes.
Whereas we can't sleep with the lock.
Yes, exactly.
And so I'm not sure that I've got the locks completely sorted out for FreeBSD. I'm going to have to, I think, get to the point that when I know that a provider is busy, I'll just have to mark the kernel loaded module as busy so that we don't need to try to unload it.
Yeah.
I don't need to hold the lock around the calls because I'm finding that to call back into the operating system, things like to list the else symbols that the T uses, I have to use, or it locks its own log when it gets in there, but it doesn't allow me to hold a Solaris compatible log outside.
Yeah, and we obviously we're able to break it up in terms of the provider of dtrace boundary reasonably cleanly. You don't have to implement any providers, including your own provider. In terms of the one thing that does help you, or should help you a little bit, is there should be fewer Solaris specific isms in pro context than not pro context. That is, once you, we don't allocate memory in pro context. You don't grab blocks. We don't do. I mean, there are some things you do, we check for threads and so on. But basically, once you're in pro context, we should be pretty much out of the Solaris isms. So I think it's a matter of taking these Solaris isms that are in memory allocation and setting up signals and so on, and got to figure out just how to abstract that. And we really turn to you for your help on that.
And that goes for the library too. For using my dtrace loader, just blindly calling, something proc function. It'd be good to identify those things so we can start pulling those out and make it easy for you guys to suck in new updates and things like that.
Well, I was going to say, for example, a very easy thing we could give people that might have helped you guys would be stuff out with the problem. Just functions, basically they're returned, not import or whatever, that just be used to start finding something.
Okay, that's fair.
So what I've had to do is create a BSD version of the main tray in order to, I can't use the word, but in order to comply with the requirements of my operating system. Just usability about it.
There you go.
So, license
Yeah, I have to have the boundary between the things that are optional and people might not want to load, like all the dtrace stuff, and still be able to have the basic distributed order to implement libcrop, because it's mostly based on the process file system, because it only handles shared code, whereas the FreeBSD I need to be able to handle statically as well. Because FreeBSD can be embedded to the point where you have just a kernel and a single threaded process running as init, and there's nothing else. You don't have to have any shell scripts and shared libraries and that sort of thing. So when it comes to an embedded system, the more embedded it is, the more you want to be able to trace it. So for that requirement, I need to be able to do static tracing. So for our libcrop, I will make it trundle through the wall stuff in order to be able to get information that it needs to trace statically as well.
I had a different kind of question, which is, I think one of the things that's a lot of fun when you work on tools, and Brian, Adam, and other people, we've done a lot of these things now. Sun is, once you have stuff working, and then other people start using it, it's sort of like initially people get excited, and then they start out by copying things that you did, and then eventually somebody comes back to you and has done something that you hadn't thought of before, or just that they're sort of an expert in there, and you don't know anything about it. And I was wondering, just sort of, for people who experienced DTrace first through what you did in your own community of developers, whether it was user-land or kernel, what people came to you with initially who had never heard of DTrace, perhaps through Solaris or other source. Just wondering if anyone had a story like that, because that's something I find fun when we get these things working.
Well, we had a bunch of, I didn't actually meet many people there who had done Solaris before, but we had some people that did some really crazy stuff. They pushed the system in ways I would have never thought of at all. They found so many bugs. It was amazing.
In DTrace or in other stuff?
In our port. I'm trying to think of. Unfortunately, most of them I can't really talk about. It generated a tremendous amount of excitement internally. The user adoption was amazing. We kept having people come to us and say, wow, I put these probes in this library and it's the greatest thing since sliced bread. I mean, it was impressive.
Yeah, because on that subject, what's especially impressive is that macOS 10 ships with many more USDT probes than Solaris. Many more.
Oh, you had your shit together so much better than we did. It was just so embarrassing to look at macOS 10. It's like shipping with you got the Ruby probes there by default. You got like all of Brendan's home directory has been copied into user bin.
User bin on macOS 10 is just like the DTrace toolkit. Just
Yeah.
If you rep for Brendan in user bin, you'll see like 30
and I would total hats off to you because you guys were able to do in a much shorter period of time what we could not make happen despite a lot of trying. So very impressive that you were able to get as much software as you were able to that shipping. And actually, I got a question that I think dovetails with Mike's question. Why did you initially engage on DTrace ports? I know the Apple guys, I'm speaking correctly, but it was more for your engineers internally than it was for your end users. Is that a fair statement in terms of the initial motivation behind DTrace? Maybe it's not, I don't know, maybe I'm misreading. Or maybe it's both.
Certainly from my point of view, it was more my department.
Right, yeah, just
to get some observability. We were just terrible problems with either understanding memory allocation, kernel, memory allocation, something like that.
Huh.
And then there was a sort of very interesting meeting about the time James came on, where I presented sort of the root memory port DTrace in front of the VP tools at the time. And he came back the next week and spun out this amazing, incredible story about, we're going to develop this developer tool that's going to do real-time graphing and this stuff, and you can write DTrace. Well, okay. Go for it. And he did it. I mean, I think to his credit, it's really pretty awesome.
Yeah, absolutely. John, how about you? Were you implementing reporting DTrace for yourself, for a client, for?
I thought it was what we needed to address one of the problems that FreeBSD has, and that is that we're not in a situation where we have a hardware compatibility list. All we have is a whole lot of computers out there and all these anonymous pieces of customers, and when they come to us and say, well, this isn't working, this doesn't work for the developer, working on it was tested on their machine. All we do is turn around and say, well, we don't know what's happening. We don't really have a way of being able to get somebody who's on the end of the barn list to be able to find out what's happening in their machine when they don't know themselves. And so the thing for DTrace for me was a big customer support thing where the developer could get them to put their effort into it, to propose a few scripts that they could email to the person to run to find out exactly what's going on with their system. And one of my aims for doing this trip here, where I've done 3 presentations on DTrace over the last 3 days, each one's running for about 3 hours, was trying to get at least the companies who are working with FreeBSD to behave the same way, so that we really get to find out what our operating systems do.
And has that been resonating with the kind of the sugar daddies of FreeBSD? Are they?
Oh yes. Oh yes. They're very keen. Very keen. So I'm presenting a paper at the BSD conference in Ottawa in May, and if they pay my airfare, I'll do one in Europe in October. And part of that is to me to try and motivate FreeBSD developers to use it on their own. But like, I don't know whether Adam might have seen when I was sitting on IRC there before, trying to talk to somebody, and I actually got asked a question about DTrace while the presentations were going on. So you want to know whether I fixed the bug and everything too.
Okay.
So, when you're finished with the FreeBSD port, speculatively
Finished.
how hard do you think it'll be to port that work to OpenBSD? And
that's part of the subject that I'll present at the conference. I'll try to present it in a way that this is basically what you need to do. It should, within certain limits, fall out fairly easily for them. There'll be slightly different modules every day.
To that point, and comment, not to get away from your motivation for it, I want to get back to that, but I wanted to see if you guys would be interested or have the time to build up some sort of wiki or documentation about porting, so that other BSDs or other operating systems can, sort of build on what the free projects have done. Is that something you would have to build?
I'd love to see like a central repository of porting information. Get all the porting points together.
That would be awesome.
I'd actually like to do you want to answer that?
Sooner rather than later.
Great, well, we'll make a wiki page like now, like 5 months ago.
From my point of view, I'd like to ask you to consider having a dtrace.org, having the main dtrace code, which is the contents of all the libraries and the tools, sitting out on a site where we can contribute our changes to with all the hash if defs. So we're all working off the same
3
code
copies
base.
of the tree, all with our own individual changes and not coming back to a central repository. It's kind of tricky to keep updates coming.
I think the first thing we'd like to see is
dtrace.org is unfortunately taken. dtrace web design tips. The best web design tips on the web.
The thing is that you could then, because I remember, was it Brian or Adam said to me once, it was possible to add hash if def FreeBSD as many of the code changes go back, because you're not prepared to have code in your tree that can't be compiled.
Yeah, it's a pill we need to.
Well, what I'd like to propose is that if you have an external site for it, we can contribute to that site, and then you just do a hash do an
Yeah, no, I hear you.
report back.
Yeah, but you can also do rely on function boundary-based separation as well, right?
Which is how
Function
general.
rather Solaris, we prefer that approach.
Well, if we could at least do that, to break up the code to break
There's a
up.
lot of
if that's what we
Yeah, it would be really nice if dtrace.c wasn't 400K and have a ton of Solaris.
Careful with your
That's not problem. No, I'm more than happy. I'm more than happy to about. Oh, you're gonna take that out? I don't think so.
It's not the comments, you go to Solaris stuff and put it off on the
The
side.
400K in dtrace.c. Look at how much that's comments.
Good point.
So not by
dtrace.c does cut up cleanly because of all the functions are grouped neatly. It's well done in that respect.
Thank you.
And I had it all divided up until I realised it was going to be so difficult to merge changes back in.
Yeah.
No, fair enough. And I think, and I totally hear the point about dtrace.org, and I think that we need to figure out a way that we can. I mean, I think in the short term it's going to be something on OpenSolaris.org, but I
don't care as long as it's in a separate.
Okay, so as long if you don't
have to get 86 megabytes of code and then go from there.
I think what we'd like to do is make it so that you don't have to have if def for BSD or if def Apple or if def anything. Just like have that off in its own file and where we stick our Solaris systems in our own file.
But
work with
Adam, I agree, but I also hear what John is saying about like, okay, yes, that's where we want to go. But right now, these guys are going to collaborate with one another, and they don't really have a way of doing that. And in particular, when we get the free VSDs and the net VSDs involved, I mean, as long as if you don't object to being an open source on opensource.org, then that's that.
You made that project on open source.
We get project on opensource.org. Yeah. I mean, so actually, we just proposed this. So we got enough DTrace, the DTrace community in the room to be able to get to kind of vote on this immediately. I would propose that we have a DTrace porting project at opensource.org, and that you four be the community leaders for that project. And if you agree to that, we'll get that going immediately. So.
What about contributing things like a different version of ELF?
Yeah, and I think
because ours supports cross-architecture types.
So
you can open one up and it will be location for you. You change them and it will write it back into a target for.
Speaking personally, I would welcome you rewriting the development Solaris.
Ours was written from scratch. We also have a version.
You from New Jersey. Yours is better.
Ours has the test web.
That's right. So, I think for starters, for sure, there's a repository where you guys can start collaborating, and then we'll figure out how we can start pulling these things into. I mean, I do want to, for the Solaris mainline, yes, I would avoid if that FreeBSD, if that can't.
Okay, but that's
but
that's something we use
that's a goal.
Yeah, but we can. So what we need to do is we need to figure out where those if networks are, and then we need to work with you to get the functional interfaces such that we can just break that apart, and we're committed to doing it.
So let me just say on this point though that it'll be very difficult to extract DTrace entirely from like the main ON tree. So one of the things that we've used to our advantage many times, for example, James, you know, in the paper provider, where there's intimate knowledge between libc and the way the paper provider works. And the only way we can make modifications in that is by actually delivering those together. So there's some reasons to get them together. I'm not saying that we can't find ways of achieving what you're talking about.
Yeah, in that case, you've also got some changes to your shared loader too.
Yes, and also the KRTL being advanced.
Yeah, well, some of those changes I'm not allowed to do those sorts of things to FreeBSD, so I've got to find another way.
Okay.
They don't like me to do things that are optional, but things that are actually requirements.
From a competitive technology standpoint, well, I think we've touched on this in a couple of the answers, but there are obviously a lot of approaches that you can take in terms of trying to introduce some of the functionality that DTrace provides. You can obviously try to make your own, as the Williams folks are doing. You can try to port it, as all of you have done. You can try to acquire it. You can try to do a bunch of different things. But in terms of the approach, obviously, that you all took in terms of going with DTrace, was it mostly a technology decision? Were there licensing politics as well? Was it? What were the different circumstances that led you to take?
See, before John answers that licensing question, I need to sedate him, so this is perfectly normal.
There's one word I'm not allowed to use here.
Elder.
The old word.
Okay.
And that's not Linux.
Yeah.
It is Linux, but it's not this one.
Yeah.
So I don't quite know how to answer that question.
Fair enough.
Anyone else? No, I didn't answer that question. So, why did you guys, were you guys at Apple thinking about other technologies or? Okay.
Well, I mean, I looked at some of the other papers and just see. And the license, we did the licensing before we had other uses from this one.
No, we didn't. We had to actually get legal approval for the.
And it was your
land code that was
the path.
not linked to the referral, so we needed to get legal to fly off on that.
Your lawyers are more chilled out than FreeBSD lawyers.
Could that be L word? Lawyers?
John's been very well behaved. Now, don't tease him.
Just cheap fineries.
It's like those kids, Todd the Tiger.
I know. I put it back.
It's a bit unfortunate actually. There was one of the companies that actually want to approach some to try and buy out that
So
they are so keen to use.
in terms of, I mean, just to Stephen's question, I mean, I guess you're asking, did they evaluate rolling their own?
Well, but I guess the nature of the question, as far as I'm concerned, is that we have, I would characterize the two major projects in space. Obviously, DTrace, certainly has the most traction from a community perspective in terms of all the gentlemen that are on stage. You know, system tap is going to get a lot of traction simply because it's Linux. It's a very, very sizable ecosystem.
And that's GPL to us, we can't.
Yeah.
Simply can't do that, that's a
Understood.
job stopper straight away.
Understood. The reason I asked the question, I guess, is that, you know, generally speaking, as an analyst, when I try to look at technologies and evaluate, you know, what's going to be more successful in the longer term, yes, the technology is fundamentally and critically important. Like, if you can't do the job, then you're not going to be able to do the job. You're not going to be around all that long. But at the same time, you know, one of the more important factors, particularly when we're evaluating open source efforts, is the size of the community, right? And I think that there are non-technical factors that come into play here. You know, certainly choice of license, the ability of Sun to relicense the code under more favorable terms, and so on, that are important in the size, the ultimate size of the communities that we can expect that will form around, you know, the different projects in the space. So basically, it wasn't. I'm obviously not trying to put anybody on the spot. It was more, you know, what were the additional factors that certainly compelled the choice in this particular case. But again,
Well, the thing is, from our point of view, in many respects, Solaris, not so much Open Solaris, was already where we wanted to be in many of the things. Because when it comes to multiprocessing, Solaris is way ahead.
yeah.
We're trying pretty hard to catch up. But so to have tools that are useful to try and improve in sort of that direction, that are open source, regardless of, you know, what limitations there are, where most of the limitations are only to do with FreeBSD being used as a platform for other companies. It's got nothing to do with Solaris and me, because I don't have any patents to worry about. So it means that everyone who's actually doing most of the developing can take advantage of what is a great technology. Where, although people mention system tap, has anybody got any case studies of system tap that really can match anything that's on there? The answer to that, I don't think so.
Cool.
I had a question, and forgive me if this is like way too geeky. I realize we're a pretty geeky audience, but pretty good for a second. So macOS 10, I believe, is running a 32-bit kernel, even though we support 64-bit.
Yeah.
No, it's not going right.
You said they're one-trick pony. Are you really going to take
different pony? So, as everyone knows, you can do copying operations. How the hell do you do a copying of a 64-bit like pointer into a 32-bit? Like, how does that work from Broadcom?
You use user adder keys, which are 64 bits, and you never copy in. Well, I mean,
Okay, you just have some routine that you can call that does the copying.
Yeah.
Just falls in. Okay.
that was already fixed by the time we got there. That was
Part of our code is running in 64-bit mode. And we jump into that to do any copies into and out of the 64-bit process and then jump back into this. We have the kernel mapped into both the 32-bit address space and a really high part of the 64-bit address space. So we can operate in both modes.
There are little micro bits of the kernel at the top of the little. I've been running that for
This was another one of our big impedance mismatches. Everywhere that you have UN pointer T, we now have user adder T, which is really bad for merges. Like the exception handling stuff, exceptions that come into Solaris are all nice and pretty. It's always the 64-bit thing. If you're ever going to talk 64-bit, we need to code that because we get a 32-bit or a 64-bit style exception.
Does this have anything to do with why you guys are still modifying PTEs from CBL3?
Good question. I don't know.
When I'm talking to soccer to do that, stop them doing that somehow. I have to clean your 2 cents.
You have to understand, Keith is like the sanitation engineer criticizing everyone had for lunch because he's down at the bottom trying
The one thing I had trouble with, or fun with FBT, and there's a few functions you had to
The test.
That was the first thing.
the blacklist!
That's the first thing I wanted to look at when you release your code. See how difficult it was for you. Because when I first did the FBT port for FreeBSD, I had a massive load with it.
So part of the failure was I could never break the kernel, bring anything back. I had to listen to the guys who knew way more about low-level details than I did. And one of the things our guy told me was, don't touch the kernel stuff, the machine. So blacklist immediately, right? And there's a set of functions that by either
experience or compulsion. Just had
So,
So if there's anybody watching this video, can you try that out just to see what
it does explode.
So, I mean, are you guys trying to minimize, because I mean, truth be told, I mean, although it's very, very small, we also have a blacklist of source, and that there are functions that we know, I mean, that the IPOC some stuff.
And this starts with dtrace, don't you?
And it is with dtrace, I mean, that we view as slightly less rancid than a blacklist. But the
reason being is it's in the code itself and it's self-documenting rather than having to keep a blacklist, which is separate, that's all.
Yeah. So
A nightmare, and as soon as we can wake up from that nightmare.
yeah. So you guys are trying to get away from the blacklist. Yeah, I mean, for us, the IPOC doesn't observe the ABI. It's called from it's like an assembly function calling another assembly function. It's like passing, arguments in G's. It's like, okay, great. It's like we obviously can't instrument that. So there are a very small handful of things that the KDI stuff. So we've got to. I just wanted to make sure that you guys are trying to minimize your blacklists.
Yeah, that's good. So there's an interesting question, right? So Unix is real-time stuff. It's, and one of the nice properties of dtrace is safety, as we think is it's a real-time system that arguably dtrace can facilitate safety.
Yeah, it's something that I'm worried about. We haven't really taken a huge amount of measurements yet. That's true. Like, I mean, probes operate with drugs off, which is like if you say that around cubes, people start screaming.
Yep.
And
yep.
why is it drugs off?
Yeah.
So.
And actually, I don't know if you are interested in discussing that your design decision. That's a very, very conscious design decision. Because it's that's how we're able to get coherence. So the interrupts being disabled, and it's not me. Obviously, given my background in Unix, I don't take disabling interrupts lightly because you're loading your real-time space. Those of you who are not in real-time space, but there's no other way to guarantee coherence on a single machine. So that's the rationale for that decision. So we got food here, and I can actually feel like people getting closer to me. I want to thank all of these guys. You guys have done tremendous work. We're looking forward to continuing work and working with you. I think all of us have got the deepest respect for all of these technologies, because this is, as you all know, and as we try to explain to other folks, like why is dtrace ported to X, Y, or Z, this is not an easy problem. It's tough, and it takes you quite a step. So congratulations again on your achievement. So let's go into the demo. I think it should be in there. It is. Where to go? We don't get more. What's that? I think there's more. Okay, so maybe dinner actually. I realized we did not actually set out the. So we might have to wait just another second on dinner, because I don't think they've got the.
Yeah, it's not very set up.
Yeah, it's not very set up. So they will be setting that up. In the meantime, it's always a good idea to drink before eating. That's right.
Good idea.
We have, thanks to the generosity of Joint, we've got the keg in the other room. And I encourage you to help yourself, and then we'll have dinner and then talk about future ideas in history. So, thanks.